morning all of you. I am Tanushri Dalai from Civil Engineering branch. So in the previous class we studied about how to calculate the normal stress, tangential stress, major principal stress and minor principal stress in the member subjected to direct stress in two mutually perpendicular directions with a simple shear stress, which is also known as a complex stress 2D system. Okay, so now comes to another criteria, which is maximum shear stress. So in this criteria, how you will find out the maximum shear stress? So here you just derivative the tangential stress and equate it to 0, by which you can get the value sigma T max, that is your maximum shear stress, which equal to half of the root over of sigma 1 minus sigma 2 square plus 4 tau square. Okay, it is only applicable while sigma 1, sigma 2 and tau is given. If only sigma 1 and sigma 2 is given, then what is the value of maximum shear stress? So in this case, the maximum shear stress value is sigma 1 minus sigma 2 divided by 2. Okay, it is only for the two mutual perpendicular stress system. Here the tau value is omitted. So now come to another criteria of the principal stress strain system, which is the member subjected to direct stress in two mutually perpendicular plane. That is, here only sigma 1 and sigma 2 is valid and tau is missing, because here only two mutual perpendicular planes are there. So for two mutual perpendicular planes, there are also two mutually perpendicular stresses also there, and the tau value is 0. So from this formula, which we will got from the normal stress and tangential stress in complex stress 2D system, from this formula we just modify this formula over here, and then we can get our normal stress and tangential stress for the direct stress in two mutually perpendicular plane system. Okay, so we know that in case of complex stress 2D system, we got the normal stress value, which is this value. Okay, and tangential stress value like this. But in case of this system, I told you that the tau is missing. That means the tau is 0. So that if we put the value in this normal stress, that means in this formula, then this system, only this value, that means tau sine 2 theta is also 0, because if we put tau value equal to 0, then tau sine 2 theta also 0. So here the normal stress is equal to only this much, that is sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 cos 2 theta. Okay, so here no shear stress is there. So according to the tangential stress, here also tau value is neglected. So if we put tau as 0 over here, then the tau cos 2 theta, this term is also 0. So only sigma 1 minus sigma 2 divided by 2 sine 2 theta is your formula for the tangential stress for direct stress in two mutually perpendicular plane. Okay. Then another criteria is member subjected to simple shear stress. That means only shear stress is applied on the body and no mutually perpendicular stresses are there. That means in this case sigma 1 and sigma 2 value is 0. So again, from the complex stress 2D system, we can find out the value of sigma n and sigma t for the simple shear stress. That is, we just put the value of sigma 1 and sigma 2 as 0 in the normal stress as well as in the tangential stress also. So here if we put sigma 1 and sigma 2 as 0, then the total term of this section will be 0. Only tau sine 2 theta is available. So now the sigma n equal to tau sine 2 theta is the value of normal stress for simple shear stress criteria. Similarly, for the tangential stress, here also we have to put sigma 1 and sigma 2 as 0 so that the total term of the first section will be 0. Hence, rest of the thing is the value of tangential stress, which is minus tau cos 2 theta. So here you can see, here written that minus tau cos 2 theta is the value of sigma t. Okay. Then now, next criteria is your member subjected to direct stress in one plane. That is, here only sigma 1 is applicable. That means the body subjected to only one plane, which is only one stress is applied on the body. Okay, so here in the y direction stresses are 0 and also the shear stress also 0. So again we take the formula of complex stress 2D system and just put the value of sigma 1, sigma 2 and tau. After that we can get the value of sigma n and sigma t for the direct stresses one plane system. So if we put the sigma 2 as 0 and tau as 0, then what we will get? We will get sigma 1 by 2 because sigma 2 is not available, so it is 0. Then second one is the sigma 2 is 0 and cos 2 theta, that is sigma 1 by 2 and sigma 1 by 2 cos 2 theta. Okay. So by which we can calculate this value, then we can get sigma 1 cos square theta. Okay. Then while we calculating the tangential stress, we put the sigma 2 0 and tau 0. So only sigma 1 by 2 sine 2 theta is the value of tangential stress for the criteria of direct stress in one plane only. So this is another formula by which you can calculate the position of principal plane. So the formula is tan 2 theta p, which is principal angle, equal to 2 tau xy. Tau xy means shear stress along the xy plane, and sigma x minus sigma y. Sigma x means the stress along the x-axis, which we can take as sigma 1, minus sigma y, that is the stress along the y-axis. We can take as it sigma 2. Okay, so these are the in general formula which you have to remember for the calculation of the normal stress and tangential stress for various kinds of criteria of principal plane and principal stress strain criteria. So here a problem regarding your principal plane and principal stress system. So the question is, a steel bar with diameter D equal to 14 mm is subjected to a tensile load of 10 kN, which you can see in the figure, and what is the maximum normal stress and what is the maximum shear stress you have to determine. So we calculate this problem in the next class. So today this much. Thank you so much.